Alright, today we're doing section 6.6, day 2. So these notes were printed for you. It's basically just a piece of paper with a couple little notes on the top with 10 blanks for you to write the problem. So if you lost the notes, just do it on a separate sheet of paper. It's not a big deal. But there is room on the back of yesterday's notes for these problems. So yesterday, remember, we practiced simplifying expressions with exponents by combining a few different rules at the same time. That's what we're doing today as well. We have to remember when we're simplifying, we're still using the order of operations. Like from first semester, we simplify the parentheses if we can. Then we focus on the exponents. Then we multiply, divide. Then we add, subtract. We're still doing that. We're just using the exponent rules that we learned in this chapter. Okay? So here's our first example. The examples are not written on the notes, so I'll give you a second to write them down. Now this is very similar to the warm-up. The only difference is now we're distributing an x instead of a 2, right? But we do it the same way as we did first semester. We have x times x plus x times 14. You're just multiplying everything in the parentheses by the x that was out front. What is x times x? X to the second power. What is x times 14? 14x. Don't write x 14. That's kind of like the grade school way of doing things. All right, we write the number in the front, so 14x. Are those like terms? No, so we can't really do anything. We're done with this problem. Like terms should always be your last step. If you can't do it, you're done. What are your questions? All right, here's number 2. Any ideas what we should do on this one? Yeah, you can multiply through by x to the second power. There's actually one more thing you can do before that. Does anyone see it? Remember, we always start with the inside of the parentheses. On the last problem, there weren't like terms in there, so we couldn't do anything. Do we have like terms? Yeah, you can do this first. Now, I will tell you, if you distribute, your answer won't be wrong. You'll just do the like terms at the end. But since we just talked about the order of operations, let's go ahead and follow the order of operations. So we have x squared, and then on the inside, we have 1x minus 12x, that's negative 11x. Plus 3. Now we'll distribute. Again, if you distributed first on this problem, it actually won't make a difference. You should get the same answer. I'm just going to follow the order of operations. Alright, so I have x squared times negative 11x plus x squared times 3. What's x squared times negative 11x? Negative 11x to the, I have 2 and 1. Third power. We are multiplying these bases, so we're adding the exponents. Alright, and then what do I have in the back? Plus 3x to the second. Very good. Those are not like terms, so there's nothing else we can do. We're done. What questions do you have? None? All right, here's number 3. I'll give you a second to write it down. All right, how am I going to start this one? Distribute, what am I distributing? Very good. So I have 2 times x plus 2 times 9. Then what?
4 times 2, 4 times x.
Good, and then I'm going to distribute the 4. So 4 times 2 minus 4 times x. Alright, go through and do the multiplication. Then we'll do the addition and subtraction. So 2 times x is 2x. 2 times 9 is 18. 4 times 2 is 8. Minus 4 times x is 4x. Alright, I'll pause there. Let you catch up. Okay, so I need to combine like terms. So I have 2 places where I see x's. What is that going to give me?
6x.
Nope.
-2x.
Negative 2x. It's like 2 minus 4. So that's negative 2 and then the x comes along. You got to keep that negative with the 4 or that minus with the 4. What is 18 plus 8? You were right the first time. 26. Very good.
Good job.
Questions? What am I going to do on this one?
Oh, no. No.
Yeah. Yeah, we need to distribute first. So I'm going to have x times x plus x times 10 minus 6x. Go through and do that multiplication now. X times x is x to the second power. X times 10 is 10x minus 6x. What's going on back here?
6x plus 10x. 10x plus 6x.
Which is what?
4x.
Good. And it's positive, so plus 4x. You're done now. They're not like terms. I've said this a couple times. I'll say it again. A lot of the times when it's adding and subtracting with exponents, students don't know when to stop. Okay? If you have x squareds and x's, you're done. You cannot combine terms that are not alike, so you have to know when to stop. Any questions? All right, here comes number 5. All right, where should I start on this one? X times x is where I need to start. What is x times x? Yeah, 1x to the second. All right, what's 1x to the second plus 3x to the second? 4x to the second power. Do I need to do anything crazy like square the 4 or multiply 4 and 2? No. Again, you got to know when to stop. Don't do more than you're supposed to. A lot of times in this type of situation, I'll see the right answer, but it's like 2 steps before your answer. So you got to know when you're done. Questions? All right, here's number 6. All right, how should I start on this one? Distribute. So I'm going to have 2x times x plus 2x times 10 plus 4x squared. Go through and actually do the multiplication. 2x times x is 2x squared. 2x times 10 is 20x plus 4x squared. What next?
2x squared plus 4x squared, and then plus 20. Wait,
Very good. What do you get when you do 2x squared plus 4x squared?
6x.
So 6x squared plus 20x. You can't actually add those because one has x squareds and one has just x's. Thank you. Questions?
like you said,
Questions? All right, here's number 7. All right, how should I start? Distribute the 2, yes. So I have 16x squared. I haven't done anything with the 16. We're not distributing the 16x squared. We're not adding it to the 2. We're not doing anything. So just write it in the front, put your plus sign. You're multiplying the x squared and the 5 by the 2. So I have 2 times x squared plus 2 times 5 plus 6. Go through and do that multiplication. That's 2x squared. That's 10. There you go. I said it during the warm-up. I'll say it again. If you don't need this middle step, that's fine. That's up to you, okay? I like to write out, I'm doing this times this. I'm doing this times this. Some students can do that part in their head. They just know, okay, well, 2 times 5, that's going to give me a 10. If you don't want to write out 2 times 5, that's fine. This step I do need to see. This one is optional. What do I do next? Yeah, 16x squared plus 2x squared is 18x squared is 16. Very good. You can't add those. They're not like terms. One has x squared, one does not. So we're done. What are your questions? All right, here's number 8. Anyone have a preference on where we should start with number 8? Put ones in front? Okay. What else?
4 to the 4th power? And 4x to the 4th
Oh,
power?
it's fine.
Add the x's.
4x.
Multiply the x's.
Huh?
She's making a face like, awesome, wrong, wrong.
It's 1.
Okay, so 1
oh, 4 times 4.
x. No.
8.
No.
1x plus 1x plus 1x.
1x times 1x times 1x times 1x. If it's 1x to the 4th.
Nope.
I'm going to sleep.
How about 1x over 4?
Nope.
1 over
4 over 1x.
No.
Just
Don't tell us when we get
X to the 7th.
X to the 7th power. Very good. You need to give each of these an exponent of 1. You're multiplying the numbers in the front. They all have 1s in the front, so you have a 1 in the front. That's fine. You didn't really need to do that part, but you guys wanted to, so that's fine. You add the exponents when you're multiplying the bases that are the same. So all these x's, I have 1x here, 1x here, 1x here, 4 x's here, and they're all being multiplied. So 4 plus 1 plus 1 plus 1 is 7.
That is smart.
X to the 7th. What are your questions? Now, the funny thing is, if when we learned that rule, I would have given you this problem, you guys would have got x to the 7th, no problem. It's keeping all these rules straight. That's the hard part. Questions? All right, let's keep practicing. What would I do on a problem like this? Yeah, so on this one, we multiply all the exponents by the 3. So it would be x to the 12th. Y to the 18th. Very good. All right, take a second to write this one down. Try to decide what we're going to do. We have 10x to the 10th, 4x to the 4th. All right, let's talk about the big old regular numbers first. What am I going to do with a big old regular 10 over a big old regular 4? Nope.
Multiple.
Yeah, that's just the fraction 10 over 4. Regular old numbers. If I had regular old 10 over regular old 4, what would I do to each of them? Divide them by 2. You're just reducing the fraction. So you would have 5 over 2. It's the same thing here. Those are regular old numbers. You can't make special rules for regular old numbers. Our special rules apply to the what? To the exponents. So this 10 and this 4 get the special rule of subtraction. Regular numbers, no special rules. Exponents, special rules. The chapter is about the special rules of exponents. So don't apply the rules of exponents to regular size numbers that you've been dealing with since kindergarten. Okay? What is 10 minus 4? 6. And would that x to the 6th go to the top or the bottom? The top. There you are. Any questions?